Hello, and welcome to the Fan-Out RDL routing demo using 3DIC Compiler. Today we will highlight some of the powerful Fan-Out RDL router capabilities of 3DIC Compiler, a unified exploration to sign-off platform for multi-die designs. Let's start by opening an example design containing two dies on an interposer. Using the Object Viewer, let's take a look at the front side bumps. We select Cell, Flip Chip Bump, and we turn off the backside bumps for now so we can look at the front side bumps. We turn on the underbump metal layer and zoom in so we can see the bumps in the multi-die design. Next, we'll turn on the backside bumps and their associated layer, which is called UBMB for underbump metal on the backside. And we see the backside bumps. Now we turn on both backside and front side bumps. And the smaller front side bumps and the backside bumps are seen. Going into the Task Assistant, under Package, under Design Assistant, we can set some special constraints for the router. Default design rules are taken from the technology file. Let's create a new non-default routing rule that defines our desired routing width. As you can see, there are many parameters that can be changed. We choose the layer of RDL1, and we set the desired routing width to 18 microns. And we apply the routing rule creation command. Next, we'll define the nets to apply the routing rule using wildcards. We will also set the minimum and maximum routing layers to use using the pull-downs. We choose RDL1 and RDL2. We can define multiple router application options to control routing results. Next, let's go into the signal route options and check the angles. We scroll down and we see via insertion patterns along with the angles. For the PG nets, let's check the PG nets and the layers that are defined. Next, we will look at the Local Silicon Interconnect, or LSI, layer routing. We will need to finish the connections from the bumps of the two dies to the top side of this LSI and from the back side of this LSI to the interposer's UBMB layer. Now we set up the die to substrate routing using the Task Assistants. We specify the bounding box for the routing along with the routing style. For the routing style, we will choose Bridge. Specify the split layers, in this case TIV, and perform the routing. The command is highlighted below. After the routing has completed, we open the error browser and we see there are 0 DRCs after the routing. Now let's check the routing result. We will go back to our Objects panel and take a look at the front side layers. We select UBM and we turn off other routing layers. We look at the vias, and by selecting and deselecting layers in our Layers panel, we can see the shapes on the layers that are selected. As you can see, each layer has its specified routing. We look at the vias as well as the bump shapes and any routes that go along with it. Now we're going to select a via on the top layer and do some manual routing. We can route any angle on any layer and automatically adjust the trace widths. You can also dynamically change the width, and as you can see, 45-degree routes are automatically made as we move the mouse. Here you can see the width is changed dynamically and on the fly. You can also shift and stretch the routing using the stretch tool. You can also create new shapes, rectangles, polygons, etc. Here we create a circular shape on a specified layer. The property editor lets us easily view and change the properties of the shape and assign net attributes, such as the name. In this case, we assign the circular shape to the VDD net. And we will delete our example test routing. Next, we will explore the PDN. We open our Design Assistant and select a PG net, in this case, VAA. Scrolling over to our attributes, we will change the highlight color to white. And we zoom into our VAA net and its associated net shapes highlighted in white. We will use a flooded plane to connect the power net. Going back to the Task Assistant, we create package metal area for the specified net. We can draw a rectangle shape to define the boundary. And we specify the net as VAA. For the layer, we will select the RDL2 layer and choose a contour method. There are many methods and parameters to configure this command. In this case, we will select the sizings to 20. The tickle command created is shown below. When we apply the command, the resulting shape on the VAA net will be highlighted, as you see here. Next, let's turn off all the layers and turn on only RDL2. Now, let's realize the power plan by creating shapes for the metal area. It is fully DRC aware. We apply the command, and we see the metal shapes created. And that concludes our demo. Thanks for watching.